Section 8.1 is on systems of linear equations. The textbook actually covers a few methods for solving systems of linear equations, but we are going to focus on substitution. Here are some examples of a system of linear equations and where you can also see the notation used. So we denote by using a bracket on the left, and then you see this is a system with two equations and two variables. And here's another example with two equations and two variables. This one actually is not linear because there is a square on the variable for y. And then, although we won't be solving any at this point in the semester, but here is a system with three equations and three variables. So general steps for solving a system of linear equations. First, what we do is we pick one of the equations, and there'll be a choice, but you just pick one, and from that one equation you solve for one of the variables, which means to get the variable all by itself on one side. And a good tip is to choose an equation that has one of the variables with a coefficient. So a coefficient is the number in front of the variable of either 1 or -1. If that's possible, that's what you want to pick because that just makes the algebra a little bit easier. Once you've solved for a variable, you then substitute into the other or the remaining equation, solve the linear equation that results, and then you substitute your answer back in to find the value of the second variable. And we're going to do an example on this PowerPoint coming up right now. So the example we want to solve is the system of equations with 2x plus 3y equal -3 and 4x minus y equals 3. So again, step one is we want to pick one of the equations and solve it for one of the variables. Now in general there's four choices. I can pick this first equation where I can solve for x, or I can pick the first equation and solve for y. I can pick the second equation and solve for x, or the second equation and solve for y. But if I look at this little tip to look for something that has a coefficient of 1 or -1 in front of a variable, I see that my only choice for that is this second equation and the variable y, because it has a -1 coefficient in front of it. So that's the equation that I'm going to pick, 4x minus y equals 3. And now I want to solve that equation for that variable. So that means I want y all by itself. So I'll add y to both sides and also subtract 3 from both sides to get y equal 4x minus 3. This is now what we substitute into the other or the remaining equation. So the other equation is 2x plus 3y equal -3, but instead of y, going to use the formula that we have for y. So in other words, the equation becomes 2x plus 3 times the quantity 4x minus 3, because we have to make sure that we multiply 3 by all of y, not just part of it. So we do need these parentheses, equals -3. This is just a linear equation. So to solve, we can distribute the 3 to get 2x plus 12x minus 9 equal -3. And now we can combine the x's together on this side and at the same time add the 9 to the other side of the equation to give us 14x equals 6. Finish solving by dividing by 14 and then reduce to get x equals 6/14, which reduces to 3/7. Okay, now that gives us an answer, but only for x, and the original system had two variables to solve for. So now what we need to do is substitute this answer back in to find the value of the other variable, which in this case would be the y. And what you can do is just come back to this original where we resolved the equation for one of the variables. We know that y is 4x minus 3, and we now have a value for x. So that means y is 4 times 3/7 minus 3, and that simplifies to be -9/7. When you're on My Lab Math, make sure you watch how they want the answers to these problems given. It very well may be set up to where it just says x equal and you type in the value for x and y equal and you type in the value for y, but it may ask you for an ordered pair, which that's the coordinates of a point, and if that's the case, then you would need to write your answer in this form with parentheses, the x value, and then comma the y value. There are some special cases of systems of equations that might pop up. The first is called an inconsistent system. You can't tell that from the way it starts off because it looks exactly like what we had before. So again, if I wanted to solve this, I'm going to pick one of these two equations and rearrange it for a variable. And I see that once again I have an equation that has a 1 in front of the variable, so I'm going to pick that equation, x minus 3y equal 2, rearrange it to solve for x by adding 3y to the other side. Now I'm going to take this expression for x and substitute it in to the x in the other equation. So that's negative 2 times the quantity 3y plus 2 plus a 6y equal 1. Distribute, we get negative 6y minus 4 plus 6y equals 1. And here we got a special case. If we combine the y's together on the left side, we end up with negative 4 equals 1. There are no more variables, and this is a false statement because negative 4 does not equal 1. So that means that there is no solution to this system, and we call that system then inconsistent. There's one more situation that can occur with a system of equations. So again, we have a system very similar to the one we just looked at. In fact, it's just got one number change. So again, starting off the same way, I see the equation x minus 3y equals 2 has a coefficient of 1 in front of the x, so that's what I'd like to start with. Rearrange to get x equal 3y plus 2. Substitute this into the other equation. And when we distribute, we get negative 6y minus 4 plus 6y equals negative 4. Now just like the one we did with the inconsistent system, we have a negative 6y and a plus 6y, so those will cancel out. But this time, what we're left with is negative 4 equals negative 4, and that is a true statement. So since we came down with something that's true, what we have are equations that we say are dependent on each other. It doesn't mean that we can have all real numbers as our solution, because we have to keep the dependency of the x and y connected. In particular, the x's always have to be 3 times y plus 2, what we solved for at the beginning. So in this case, the way we write the answer is to just say the solution is all points x and y, where x equals the formula that we had, 3y plus 2. And that is how we do a system of equations.